And Sylvie, are you ready? I'll let the people in now. All right, I'm letting everyone in.
Good afternoon, everyone. We just opened the room and letting people coming in, and then we will start in 30 seconds.
Wide knowledge of how the ERM business works, because it's, and it, I guess is that.
Good afternoon, everybody. I'm Sylvie Russell, and on behalf of, I'm the head of operation at Cambridge Cleantech, and on behalf of Martin Garratt, the CEO of Cambridge Cleantech, and the full Cambridge Cleantech team, I would like to welcome you today for this webinar. This is part of the Smart Sustainable Home SIG, and today we are going to look at the Home Energy Management System, or the abbreviation HEMS for those who are familiar with it. So welcome everybody. We had a great speakers today. Today, as a reminder, is also the Clean Air Day. So I'm sure we're going to hear a little about that within these smart sustainable homes. For those who don't know Cambridge Cleantech, we are a networking organization, and we do run a special interest groups such as this one. You check our website, we have more about finance, smart cities, energy, and so on. We also do access to finance through our Cleantech Venture Day, and a special one and a special mention to the next event that we will have soon. I think it's the 1st of July. About doing business to the US. So if it's the first time you're coming to this event, welcome. And do check our website and sign up to the newsletter for more information about what we can do. But today it's all about the Home Energy Management System. I will ask you to stay mute if you are not a speaker, and type your questions into the chat. You start your chat by saying question, and then we will have all the questions will be gathered and asked at the end of the session. We will also have time for breakout rooms. So thank you everybody to be here with us today. I'm sure some of you would like to be in the garden, but there are more important things to do just now. We can all improve our houses. And Peter, thanks for facilitating this special SIG. Peter, over to you.
Hello, thanks, Sylvia. I'm just going to share my screen, and then I'll be able to start my presentation. Welcome, everybody. Welcome to what is now the 9th edition of the Special Interest Group. And if I'm just going to make sure my slide is right. And I'm just going to get it to, oops. Just have to remove some pictures, and then I shall hopefully be there. I'm trying to make it. It's not showing fully, is it, Oriane, currently?
No, not yet, Peter.
Okay, so I want to set it as a slideshow. And then start from the beginning. Okay, hopefully you can see the full screen now. If you can just confirm that, Oriane.
Yeah, we can.
Okay, so welcome everybody. My name's Peter Bates. I've been running my own consultancy company for more than 32 years now. And one other thing I have actually been doing is also turning my own home into rather like a living lab. So I'm going to start off and actually explain what has been happening to my own home, and then explain what is the purpose of this event today. So loosely called Confessions of an Early Adopter. But just before I start there, this is just to remind people what the Sustainable Smart Homes Special Interest Group is all about. We'll be going over for about 18 months or so now, And as I say, this is the 9th event. We're mainly focusing on the 27 million homes in the UK and their domestic properties. We're not tending to not focus on commercial or non-domestic properties as far as this seeker is concerned. But now if I kind of move on to a couple of the challenges which we have before I talk about my own home. So according to Catapult Energy Systems, they said that it's not a blanket top-down approach, is not the solution to dealing with homes. And it's very much better to be a bottom-up approach, because one of the problems which exists is in the past, when there have been improvements to properties, whether it be putting in various building services, or for that matter, the fabric of the property, it has tended to be one solution fits all. And it was emphasised in a report that came out a couple of years ago by Dr. Peter Bonfield, who was the CEO of the Building Research Establishment, that in fact, every home is unique, and that must be emphasised, that there isn't necessarily one solution for every home. Another something to consider, at least what the Catapult Energy Systems considered in March 2020, is that there are still 2/3 of homes are suffering from damp, draft and overheating, and they are wasting energy. And something like half the population, and probably still not far off that, I would suspect, have no awareness of carbon heating, or how to actually make homes carbon neutral. So one of the key challenges, I think, as I want to kind of talk about today, is all about optimization, integration and interoperability of building services. Now, what I mean by building services is basically boiler in the home, immersion heaters in the home, and anything actually provide heat and hot water can be called services. So if we look at my own house and what is my decarbonisation roadmap, normal 3-bedroom, 7-detached house, built 1975. I've been in it for over 25 years. I've done probably as much as I can do in terms of taking the fabric first approach, in terms of loft insulation and in terms of cavity wall insulation. I've done that. What I really need now, but it's not the purpose of today's event, I really need some nanotechnology which I can spray across my cavity wall, which will provide the perfect insulation. That's what's possible. So I've done as much as I can anyway, although I'm still looking out for that as an innovative solution to emerge at some stage in the next few years. What I had until recently was a 30-year-old mains gas boiler with the traditional thermostat and normal radiators. And I've gradually over the years been decarbonising my home, as you'll see. About 20 years ago, I was installed solar thermal. I'll be honest, it wasn't a strategic plan 20 years ago. I probably got conned by a bit like equivalent to the double glazed salesperson, and actually was encouraged to buy solar thermal. Having said that, it actually provides me with basically free hot water for 5 to 6 months of the year, and it's had a little. That expansion tank has been replaced. There's been a couple of services to it, but it's still going. And I've got probably 70, 80 degrees of hot water sitting in my tank, which I can't use because it's too much for me. I keep wanting to send it to my neighbour. In 2011, 2012, I took advantage of the feed-in tariff for solar PV. So installed that on the roof of my house and also on the flat roof of my garage there as well. I decided, because I was very aware that there is a potential for battery storage. So in 2019, I forked out something like, at that time, just under £10,000, just under £2 less than £10,000 to put in a 15 kilowatt battery storage system. It is an experiment. I wouldn't expect most people to put that in their own homes, but in fact, I thought I'd try it out and actually see what I could do with it, because I was particularly aware of tariffs like Octopus Energy's tariff, where there was the ability to be able to buy electricity when it was cheap and then sell it back to the grid when it was expensive. So I remained until, I remained until 2000 and July last year. I was on the Agile tariff that some of you would know about, but I then, due to the costs, as most of us know, of electricity, I've now gone back to equivalent to an economy 7, but in my case, my off-peak is between 8:30 and 1:30 in the evening and very early morning. I then experimented with intelligent electric heating. I also experimented with these smart plugs and actually found a nice, neat solution under my garage office where I could put a 15-watt heater and then set a timer using the Tapo smart plug to do that. Most of those otherwise, by the way, just got to do with computers and printers. I then decided that I heard about the Parshaper project, which you're going to hear more about later on this afternoon from the Carbon Co-op based in Manchester. And I said I wanted to have an electric charging point. So I decided to go and buy an electric car to make that possible to do it. But having said that, to be fair, it was a 13-year-old ICE car. That's internal combustion engine car, and it was about to be renewed. So I chose the time, probably got it nicely right in order to buy an electric vehicle. And comparing the cost of an electric vehicle to an ICE vehicle, when we're talking about quotes of £100 to fill up the tank, well, I get something like 235 plus hours and that miles, and that actually cost me about £4. But then I had the opportunity to get a Wallbox Quasar. It was actually given to me by Wallbox as part of a beta field testing trial, which I could use my Nissan Leaf for. So I've got the ability with this charger, it's bi-directional. I can charge back to the home, I can charge back to the grid, as well as charging from the grid back to the car. That is probably fairly unique. It was probably 2 or 3 years away that in fact it would start to take off, that type of technology. And it won't use the system of CHAdeMO, which is one method of charging a car. It will use the CCS method. I can't remember what the acronym is for CCS, but somebody I'm sure will come back to me on that one. Then I actually, in January this year, had the opportunity to take part in the Energy Systems Catapult, a government-funded organisation, and take part in their Living Lab. And I had the opportunity to get some smart TRVs, which is the thermostats that sit on radiators. Normally, you can only manually control these, but these all work automatically with an app. So I'm moving a bit further along. I'm getting much more control over my own heating system. I also took the opportunity in April this year to add a third solar PV array, which was because I discovered that this inverter on this battery storage system actually is a hybrid inverter, and I have the ability to be able to transfer the electricity generated from this via DC into direct current into the battery. The way it was originally set up on my other two solar PV arrays was it was by what I believe is known as AC coupling. And again, I finally managed to, in April this year, to remove my 30-year-old boiler, which was sitting here, and I've decided to replace it with an electric storage boiler. which unfortunately, because it was installed at the end of the heating system, I've not been able to fully test it out yet. But I was able to get off gas, get the gas meter removed, and get it capped, and only utilise, well, hopefully only utilise off-peak electricity to do this. So I've got to the point where I've now decarbonised my home. If you actually think of just removing all the devices, is all about decarbonising the home. My next stage, and this is the whole purpose of today's event, is to look at how we can I want to know how I can optimise it, integrate it, and also make them interoperable, those various building services which I have, in order so that they will talk together. I'll be able to optimize electricity generation, reduce overheating loss, and minimize my carbon emissions. So what do I need? Well, this is what I need. I need to know how, well, one problem I've actually got currently is that, or at least I did up until recently, have the problem of, because the metering system for my solar PV and my battery storage system was only capable of dealing with the first two solar PV arrays. I had to have those disconnected and then have when I had the new solar PV arrays, and it wasn't telling me my overall export from there. But we have recently solved that one with an open source solution with the help of Matt, who's our last speaker today. But there are all sorts of other issues which emerge there. So although I'm an early adopter, I think we're now getting to the stage where there are, in fact, we need to look at some of these issues of how to make them work together. And quite often early adopters would buy a bit of this and buy a bit of that. Now, I fully admit that, in fact, most people, when they finally get to the point of decarbonising their own home and possibly removing their oil or mains gas boiler, there'll be much more integrated systems available for people at that time. But we're not there yet, and that's what I want to be talking about today. So I'm now going to move on to our first speaker, who is James, who's going to introduce himself, and I'm going to stop sharing right now for you, James.
Hi all. Hopefully you can see my screen on the right screen. So yeah, my name's James Harrow. I'm from Green Energy Options, or GEO as we're known, and I'm going to talk to you today about home energy management futures. And very much like Peter, I am an early adopter and have gone on a very similar journey, but not exactly the same. And I think that's a key point to talk about when we look at consumer journeys. So I think, Peter, you started off with some sort of solar, you got battery and then an EV. And in my case, I got an EV and then I got solar and a battery. Because at GEO, I was leading the core for grid demand side response and home energy management system. I was lucky enough to be able to be, both technical to actually integrate our solution together with my own different battery that's not the same one that we used on our trial. But I'm going to talk to you today a little bit about when you really need a home energy management system and why you should have one. And at the moment, if you've got, say, solar and battery, those two things can work pretty well standalone. Battery inverters are designed to have a current transformer that detects how much export you would be exporting to the grid. That just clips around your mains connection into your home, and that automatically charges. And when the sun goes down, it will automatically discharge to power your appliances. But if you then got an EV, again, a solar and EV chargers do exist today, and they work pretty well. Again, the same sort of thing where the EV charger stops you from consuming any power from the grid and only consuming from your solar panels. But as you start to add new, you're going to on this decarbonisation journey, and my next purchase is likely to be a heat pump. So I'm going to struggle to work out how to control all of those things and reduce my import from the grid, and also make sure that my washing machine and other white goods appliances can be controlled in a similar way. But I think it is really important to talk about early adopters and mass market, because there are systems out there today. And as Peter sort of mentioned, he's starting to find the bits of kit don't work together. They were never designed to work together, and that's what we need to address for the mass market. So let's talk about those optimization things that you would want a home energy management system. And the dream is that you, as a consumer, you don't have to do anything. You just literally set the system up and then it does everything for you. And again, on our corporate grid trial, we had sort of built a solution which would do that. For example, you want to look at the cheapest times of day, so knowing when the tariffs are going to be cheaper, but also taking into account things like the grid carbon intensity. So the more power stations we need on that are burning fossil fuels to power the grid, the more CO2 is produced by the population across the whole country. If you're lucky enough to have solar PV, then you've probably got a different optimization. You want to say, where does my solar go? Do I put it into my battery or in my heat pump, or do I put it into my EV? And maybe you can do some of them simultaneously. And it's really when you get more than, I would say, two or three energy smart appliances that you need to have something that takes care of that for you. And I certainly today manually have to work out when to put my EV on charging. I have to go down to the EV, reduce the charging rate, because my particular EV charging system doesn't yet have that capability to limit the charge rate for the amount of export. So there are challenges. So if you've got solar, that's great. You can work out where you put the energy during the day. Once the sun goes down, then you probably want to make sure that you're powering things in the home. You may pull some power off the grid. But at night, you probably want to charge your EV. And there's a general principle here is we try not to first charge one battery and then discharge it and put it into another battery, because you lose about 20% efficiency in the round trip efficiency of going from in and out of the battery. So it's always better to charge your EV directly off the mains if you can, rather than taking the power out of your home battery. But there's another reason that you really need to look at why actually government wants you to have an energy management system. And in last year's Climate Change Committee budget, they said that out of the 28 or 27, 28 million homes in the UK that exist today, by 2050, 21 million of those will need to be on having a heat pump fitted. And the government's already started announcing plans to get us to 600,000 heat pumps installed every year by 2028. But we've done a white paper with Valent on heat pumps and the impact on the low voltage network. So what do we mean by low voltage? We mean the 230 volts that feed your house. There's some transformers and substations that you'll see around your houses, your villages and your towns, etc. There are cables that then feed that electricity into your house. And we did some calculations which show that if somewhere between 10 and 20% of homes converted from gas to electric heating and cooking as a consequence of getting rid of your gas meter, then that's probably going to start causing issues on the local grid. So we need to be really careful about when we charge our vehicles and when we use heat pumps in order to avoid power cuts and issues on the local grid. So there's a whole technology sector that's growing called demand-side response, which is really already there for industrial and commercial applications. But as I say, we've looked at the modeling for the peak times of the day, and you can see, between the 4 till 8 p.m. time period is when everyone comes home, they start cooking, they put the lights on. You've probably still got some shops and offices open where they're also using power as well. So the peak on the grid is at that point. Now with EV charging, if you get a new EV charger this year, it will actually by default not let you charge during those periods, during peak times, and it will encourage you to shift to overnight charging. But with heat pumps, etc., we can't really turn off heat pumps during that time. So we need something to control the heat pumps and also the other white goods appliances in your home. So as it stands today, there are lots of existing and possibly open standards that are there. But your solutions you buy today, you may find that you actually get locked into a particular vendor or a particular group of companies where their equipment works together. So you can imagine if today you bought a Tesla Powerwall and a Tesla EV, you'll get a really good experience. But if you decide to move away from Tesla and buy a Jaguar I-Pace or some other EV, that wouldn't necessarily be compatible with the Tesla Powerwall, and you wouldn't get the great same experience. There are lots of trial systems out there today, and Peter's talked about some of the ones that he's already on. As I said, Geo's done a government-funded trial a couple of years ago on how to build a home energy management system, but it's not yet really sort of a mass market. As Peter mentioned, the CHAdeMO charging standard, which you can do vehicle to grid, is not readily available in the newer European standard for the CCS standard. And again, I can't remember what the CCS stands for either. So, but there are some standards coming along. There's a great one called EE-Bus that is being adopted by German manufacturers. And that is really that whole home energy management system, and lots of protocols that operate inside the house to do that sort of thing. But again, it's not really globally adopted. It's not used by America. It's not used, internationally. The UK is also working on or has published last year, this publicly available standard 1878 for energy smart appliances, and that's really all about trying to get the ability for grid services to control home energy management systems in the home that can then control energy smart appliances. Again, that was published last year. There's lots of discussions going on within industry on how do we take that forward and make that into real products that people can actually buy. So where are we now? I guess the key takeaways are we're not quite there yet, but there are really some compelling reasons for having a home energy management system. As Peter's already outlined, the early adopters want to optimize their PV generation, reduce their energy bills and reduce their CO2 impact. And grid operators really want to avoid having to dig up the roads and replace all those substations around our homes. And also there's a national grid impact as well as that. So this is where we need the demand side response. We have not really got the interoperable HEMS and ESAs. So the HEMS being the home energy management system and the ESA being the energy smart appliances, but they are coming. But we do need standards and we need alignment amongst the manufacturers of those before the HEMS home energy management system vendors can actually build those products and make them mass market. So you can, as I say, get solutions today. You may not find a single vendor that supports all of your individual devices that you've got. You're more likely to have to work with open source, and actually if you're technical enough, you can probably build your own system together. But again, that's not really a mass market solution. Partner organizations may well work together. You might have a heat pump vendor working with an energy provider that controls your heat pump, but you might not find your energy provider works with your particular EV charger. So those partnership organizations need to be built as well. But I think there is a very bright future, but again, it's all about putting the consumer first for mass market. So we need to look out for a new standard that's coming out this year. There is quite an exciting development going on. You may have heard about it, you may have read about it in the press, but there's something called Matter. It is being developed by Amazon, Google, Samsung, and Apple as the four big digital giants that you'll probably have heard of, but there are hundreds of other companies involved in this, and that's across Asia, Europe, and the Americas as well. And we're expecting to see those first products launch this autumn. So that will have things like smart thermostats, smart light bulbs, media, hi-fi, automatic window blinds. All those sorts of products are part of that first tranche of delivery in this autumn. But energy management is clearly on the roadmap, and there's lots of discussions going on. And we'd expect to see the first products maybe coming out next year on that. But I think going back to the government's desire to try and get to mass market, they need consumers to be able to adopt these products so that they can do that peak load control to avoid those overloads on the local grid. And consumers need to have a trust mark, some sort of way of knowing that they can actually buy products that will work together. And we're I keep talking about HD ready TVs 20 years ago, and I think it's probably time now we start having an industry consortium of something like DSR ready or Wi-Fi ready or USB, all those sorts of things that people as consumers can buy into and know about. So that's the last slide from me. As I mentioned, we wrote this white paper with Wayland. It was so big that it's actually been split into 3. So if you want to have a look on our website, you can see the first 2 parts, and the third part is coming. So with that, I'll hand over to Mark and let him continue.
Thanks very much, James. Let me just share my screen. Okay, that should be up at the moment. Okay, Mark Lufkin, Wondrwall. We're effectively a company that designs a solution that does what Peter's done in his own house and actually addresses some of the bits that he wants to do into the future as well. So let me explain. One thing I will say right up front is one of our primary goals is actually around affordability of the solution to put it in. So our solution, total solution, as I'll describe it here, costs the same as Peter paid for his batteries 4 or 5 years ago alone, and it integrates a battery, but it should be affordable to run. So we actually believe that affordability of the running of the home is a priority versus just decarbonisation, on the basis that a home which is cheap to run is decarbonised by nature. However, a decarbonised home doesn't necessarily result in lower running costs. So we do believe that cost is an important point. We actually started life as a home automation company, and our goal was at the time not, well, 2 things. One of them was not control your home from a phone, telling the system what to do. And it was also to integrate lots of multiple apps into a single platform and in a single app. What we were thinking of is effectively to give the home a brain. So our model was more along the lines of a self-driving car. So lots of sensors on the car, process that data with artificial intelligence, the car drives itself, or the AI drives the car. So we applied the same principle to a home, lots of sensors in the home. We feed that data into an AI, a cloud-based AI of our own, and that AI runs the home automatically. The brains behind that is our own design of light switch. So that light switch here turns lights on and off as normal, but it integrates 13 different sensors. By replacing all the light switches in the home, we build a network of 100 to 200 sensors within the home that are monitoring how people use their homes, the environmental performance of that home, and also the energy performance of that home. And that data then feeds into our AI. So to give you a better idea of that, one of our homes will gather roughly 20,000 data points per day per home. So that's about 6 to 7 million data points per year from a single house. That data then feeds into our AI. That data is important for 2 reasons. One of them is artificial intelligence gets more intelligent the more data you can give it. So the more information it has, the better it functions. So this data set is what allows our AI to outperform anything else in the market. The second point is, as we implement these solutions into homes, we want to be able to monitor whether they're actually performing as expected or not. So that concept of post-occupancy monitoring is built in as standard. We already have that data built into the system. It's not an afterthought. As that data goes to the AI is basically focusing on a few different things. The first of them is obviously to reduce energy consumption. So at a simple level, that would be, let's say you get home at you get up at 8 o'clock in the morning. The home would learn that pattern. It also knows that the home will maintain its ideal temperature for, let's say, an hour. So it'll automatically turn off the heating at 7 a.m. So it's being intelligent by automatically controlling the heating to maximize energy savings while keeping you comfortable. We do go beyond that, and I'll explain it in a second as well. But the second part of it is once we've reduced the energy consumption sufficiently in the home, so reduce down the heating consumption, hot water consumption, and so on, we can fit sufficient solar panels on the roof of the house or the home to go net zero. So generate as much as the home consumes in a year. What the system does in summer, it's dead easy. It runs the home off solar during the day, charges the battery, heats the hot water tank, and then runs the home off that stored energy overnight and repeats the cycle each day. Any surplus solar is exported back to the grid to generate a revenue stream, which is offset against whatever we have to import. In wintertime, what it does is it's predicting next day's solar generation based on weather forecasts. It predicts the energy consumption based on the historical patterns of energy consumption, and then automatically buys in off-peak energy to charge the battery, heat the water, heat the home, and then any available solar is used to top that up and run the home during the day. And then you run as long as possible off the stored energy through into the evening. The side effect of that, of reducing the cost, so the main focus there is on cost reduction, is that off-peak energy also tends to be low carbon energy. So it automatically decarbonizes the home, but that factor of looking at carbon intensity is also built into the system. So looking at that energy performance on a summer's day, as I said, basically the home runs totally off solar. So everything in darker blue is good. That's running off solar or off stored energy. So you're effectively running your home for free. In winter, you can see on the left-hand side, importing energy off peak to charge the battery and heat the water. Run the home off it during the day, the blue piece, and then you run out in the early evening and you start having to import energy again. A larger battery or a larger hot water tank would allow us to go and run that further, but it's economically difficult to get the ROI right at the moment. But with battery prices coming down, that won't be a factor into the future. In terms of the heating solution, the way we do it is the system zones the heating. So we learn temperature preferences for each room, when that room is occupied and when it's empty, and how quickly that room heats up and cools down. In doing so, if you think about it, even when you're home, you're typically not using more than 1 or 2 rooms in your home. We can significantly reduce the energy consumption, so by up to 70% versus a traditional home by using this occupancy method of control of the heating within the home. We use ceiling mounted infrared panels, typically speaking, for this. They're easy to install, relatively low cost, they're zero maintenance, and most important from our point of view is they're very responsive. So the AI gets the prediction right, detects that somebody's in a room unexpectedly, we can get that room up to temperature very quickly using the infrared panels, whereas it's not possible with a slower heating system, I don't know, underfloor heating, for example. The solution is built up into multiple pieces. So from a retrofit point of view, we would initially build in a monitoring and basic management solution. So whole house heating controls, don't heat the home when it's empty, but also with that ability to monitor the performance of the home and push out messages to it. This integrates into a landlord dashboard, which allows the monitoring of all of the housing stock. So we're talking social housing. We can monitor all of those houses, both in terms of the performance of the homes, but also build in notifications for maintenance issues, damp, for example, or for safeguarding of vulnerable people, fuel poverty, identification of fuel poverty. On that platform, we can build the other pieces. So the heating and hot water system, infrared panels, or it could be underfloor heating, or it could be any other sort of heating for that matter, and the hot water system, and the solar PV and energy. They are modular, so you can put them either all together or different pieces can be used individually. Put all of them together, you get our net zero solution for a full net zero performance capability out of the home. In terms of a little bit of data, the slides will be shared afterwards, I believe, so you can go and reference this, and I have a few additional ones. But just looking at the infrared heating on its own, this is independent data from SRE, from an actual home. The infrared outperforms gas and air source from an energy consumption and CO2 point of view in the particular house that we looked at in this case. And it's lower cost than the heat pump, although not as low as cost as a gas boiler, given the lower cost of gas versus electricity. When you integrate in the full HEMS system with the solar, the battery, and everything else, the performance is significantly better. Obviously, no solar with gas or heat pumps in these cases. You could add them, but the Wondrwall solution on its own is roughly the same as putting an air source heat pump in without the solar. So you get better performance for the same price. Just a couple of other last little things. This is actual data out of the home. One of my points around homes is by using these sorts of systems and looking at what you're doing, heating becomes less of a factor. So in this particular home, it wasn't a passive house standard of home. It was decent fabric, but not super fabric. Heating was less than 20% of the energy consumption of the home through the total year. So it becomes important to look at other factors like hot water, like the appliances, and of course the EV as you manage these homes and look to reduce costs and decarbonize them. And then from an annual basis, I thought Peter was going to talk about his ripple energy wind integration, so I was going to make a comment about it, but what you can see here is the solar is generating half of the energy required for 70% of the year, about 8 months of the year, roughly. Wind would integrate and complement the solar because you get better generation from wind in winter versus summer. So one of the things that we're looking at is the integration of wind turbines into the system to go and complement solar to give a better balance of generation through the year. Just a few things that we go and sell to, people that we sell to. We are installed already. It's a commercially available system, which has won multiple awards. So if you've got any other questions or would like to know more, happy to talk to you. Thanks very much.
Super, thank you, Mark. And now we'll have John Scott from My Global Home. John, over to you, and I think you're on mute.
Apologies. Can everybody hear me now? I assume they can. Yeah, great. Hi there, my name is Jonathan Scott. I'm the Chief Revenue Officer for My Global Home. What I'd like to start talking about here is the initial image that was used to describe this presentation today, which showed a home in the heart and then around it lots of different elements that make up a smart integration of home. So our principle and founding ethos within the business is to actually create homes that look after the residents. And actually, I'm going to sort of pull slightly on what Mark's mentioned a minute ago. You know, we are an automation company and we have started with that at our core, really. So we've looked at the market and thought, well, there needs to be a way in which all of these independent items that are being put into the marketplace can be brought together in such a way so that it becomes a system that can be adopted more widely into society. So we've taken that approach at the outset, really. So we're looking at it from a trying to adopt an overall integration within the marketplace rather than becoming individual with the way in which we're looking to apply ourselves into the market. So our starting point has actually been around the home control. So we've devised and we have a system that is able to control the standard and conventional elements within your home: heating, lighting, automating blinds, entertainment systems. You know, we've put a system together that can achieve all of the base functionality that people would like to have within their homes if they're choosing to have a smarter option. We believe that actually it's about bringing together all of the functions, as I've stated, and it's about actually using the application of software, as Mark actually has highlighted with the software that he's got, you know, to actually represent that data to be useful to the homeowner. So it isn't just about turning the lights on and off in various rooms or the heating up and down. It's about having systems that understand where people are within the home, how their consumption of different items and use of the home is actually adapting over time, and how the behavior then can influence the use of things like energy within the home. So, we're taking that holistic approach to the overall smart home application, and we're taking a slightly different approach again in the fact that we're putting in edge devices. So by that we mean we are effectively putting a server into the home, which becomes the part of the home that then is controlling the main processing, and is not then reliant so much on the internet for base functionality of the home. So if you want to turn your lights on and off, the server makes that decision rather than having to use the internet for it. Obviously data can be uploaded out to the cloud as and when required, but it doesn't have to be constant. It can be something that is done on periodic. So this means that, by approaching this way, we believe it allows for, significant expansion of the software capabilities of the home and a greater ability to integrate with a wider pool of appliances and manufactured products out in the marketplace. So how have we taken that approach, and how are we looking to provide that base control of the home? So what we've chosen to do is partner with a number of established businesses. So our main automation and control gear, effectively, or the control element, is provided by a company called Beckhoff. It's not a household name, but Beckhoff is a company that automates predominantly building management systems and also automation of production lines and manufacturing. So the Beckhoff kit runs all of the Tesla production worldwide, is the main driving force behind the BMW production lines. They're actually specified on the Intel factories, which manufacture the chips. And at the moment, there's a significant problem because Beckhoff need to actually deliver more Beckhoff kit to the Intel factories that are going to be built in order to build more chips so that everybody can produce more electronic equipment. So sort of a cyclical part of the component issues that are in the supply chain at the moment. But Beckhoff are an incredibly reliable, proven automation engineering company, and they are at the heart of our control system. We've then worked with a company based in Saudi Arabia and also in the UK called Alphanar to then take the control kit and put it into a conventional form factor. And by that, I mean a distribution board or a fuse box that can be put into, at this stage, a new build home and then integrated as part of the fabric of the building. So when a new build home is built with our system, they have a very powerful edge-based device, which is effectively an industrial PC, helping to make decisions as to how the lights and heat can be controlled, but also then gathering significant amounts of other data. We are actually based at the University of Surrey. We have offices in the University of Surrey and also in London. And I'm actually based in Surrey today, and we've worked extensively with the university here to develop out a number of the different sections. We've been funded previously by Innovate UK, and are still supported by them as we're taking the product further into the market at the moment. So on the screen at the moment, you have an example of a light switch and also a 3D render of a distribution board. So an app that can help to control your home. You can also choose to control your home via the devices that are around the property. So by that, I mean the thermostats and the light switches. It means that from day one, anybody moving into a home or living in a home with a system like ours could control the home just by going and turning the light switch on and off as you would do normally, or turning the thermostat up and down. But if they choose to, they can interact further with the property by downloading an application and then controlling and interacting with the home in a different way. So, you know, layers and layers of different ways in which we can actually work with homeowners, but also different providers of hardware and software into the future. So this is where we were able to layer that meaning into our products. So, you know, when we're looking at the different images on the screen here, you know, what we're talking about today is reduction of carbon and how home energy management systems can be brought into the picture. But we think equally of importance is to look at things like the maintenance aspect of a home. How can your home be better maintained if you've got a system that understands the asset register of everything that's within the home and can tell you when things might be looking to fail? Healthcare, again, mounting sensors around the property as we also do to collect numerous amounts of data points. It can help to be a good indicator and a pathway that can aid with the application of in-home healthcare. So to move on to energy management and home energy management systems, our distribution boards have current transformers mounted within them. That means that every incoming way into the home is monitored to see the level of electricity that's being consumed. That can then be visualized through the application so that people can actually see the level of use of their home through the different zones. And that then feeds into the very capable and powerful back-off control system that can process significant amounts of data to then enable the home to learn and adapt to the needs of the occupants over time. So here's an example of an installation that we have in a new build development, which is on the screen at the moment, where we can see an application of the thermostat unit, which includes a PIR, so a proximity detector. It has a number of other sensors within it, which cover the majority of what was mentioned previously by Mark also, temperature, humidity, VOC, CO2, particulates, and a number of others that are also within. So space control of the home that will enable for intelligent living and also the ability to understand and see the control of energy used within the home and open for integration with other third parties. We are not at the retrofit stage yet, so that's my parting comment. We're not ready for retrofit, but we are developing our retrofit model for 2023 in conjunction with all of our partners. So that's my final slide, and I will take that opportunity to pass on to Matt from the Carbon Co-op.
No, it's actually Irene.
Ah, Irene. Oh, I'm very sorry.
It's fine. And I think everybody can hear me. So I'm going to
Yeah, we can hear you well.
share my screen. Okay, hopefully everybody can see the screen. So thank you for having me this afternoon, and everything that I've heard so far is very relevant and very interesting to what Ampex is doing. I lead Ampex, which is a digital energy platform player, UK-based, fully owned subsidiary of a company called AMP, which is a renewable energy infrastructure developer, owner and operator, headquartered in Canada, but with a global footprint. Today, with about 7 gigawatts of energy either on the ground or about to be on the ground. So I'm going to be speaking to you today about one of our products. But before I do that, I think it's fair to give you some context as to what Ampex has been focusing on. So as I said before, we're a digital energy platform player that has been working on a number of interoperable products that are all aimed to the edge of the grid. For us, the focus is the edge of the grid because due to the increase in decentralization, it is clearly the locus of the greatest challenges for a number of stakeholders, system operator, network operators amongst the ones mostly impacted. And for us is the locus of opportunities, because addressing those challenges with a whole system approach, which is what we have been taking, in our view, will unlock a number of many new business models, opportunities, additional revenue streams for different stakeholders. So we have developed a smart transformer, which is proprietary to Ampex. It's a piece of infrastructure upgrade, which is destined to the low voltage network. It's a replacement of conventional transformers, and it's got the ability, thanks to an onboard processor, of dynamically adjusting voltage, which clearly is one of the challenges the network operators face as a result of increased presence of distributed energy resources at the edge of the grid. And the smart transformer is going live in a few weeks in the UK with one of the largest TNOs. And it's going to prove not only that it can solve problems at the node in terms of voltage, power factor optimization, but also able to be coordinated as part of a fleet of same systems to provide synthetic inertia and therefore enable DNOs to play in local flexibility markets or even provision of ancillary services in the future, which we know is very important with the changing landscape of DNOs, DSOs. We've also got a live virtual power plant solution for some of the AMP assets in North America that are comprised of batteries in merchant markets. They need to be optimally dispatched, and this is what the AMP asset management platform does with real-time monitoring and control, and through the AI engine that would go cloud hosted, there is obviously an optimization of that dispatch against price signals. And then we've developed a behind the meter solution, which is what I'm going to be talking to you today. And it's aimed to unlocking flexibility at a very large scale to be able to play into demand response constructs, which clearly aligns with some of what my peers have been talking about so far. So all our products are differentiated in that not only do they have full automation that clearly is expected for all solutions these days across our sector, but there's also the concept of autonomy, which we actually have been leveraging. And that is a concept that is very well established in the defense sector already for more than 2 decades, where local decision-making capabilities was key for a number of solutions specific of that sector, whether we have envisaged to have a relevance to our energy sector as it gets more and more decentralized. And the starting point for that awareness and then, in our view, the need to have autonomy at the core of a number of products is the fact that there needs to be central command, but there cannot be any longer central control. Having such level of decentralization imposes that if we want to unlock flexibility at a large scale and involve a variety of different nodes, we need to have the ability for technology to enable decision-making locally, and at the same time, decision-making that moves away from reliance on people, on human beings, on ourselves as the end user, that cannot be repeating behaviors consistently and in response to, for example, dynamic tariffs that change every half an hour in order to optimize energy consumption or to adhere to specific requirements of demand response constructs. That simply isn't scalable. And we know that because behavioral demand response hasn't been successful at unlocking the level of flexibility that is required today if we want to involve the edge of the grid behind the meter into a number of flexibility service provisions. I mean, I always refer to one of the most meaningful stats that the Smart 10 has published a year or so ago, stating that today in Europe there's about 200 gigawatts of DERs installed, of which only 1.5 is currently used in demand response dispatched constructs, which means that clearly we have a huge level of untapped flexibility behind the meter that we need to do something about. And to us in Ampex, the biggest hurdle to that unlocking of behind the meter flex is the relationship with the user. It is how we not only have a home energy management system, which is holistic, and some of my colleagues have already presented some of the solutions, but it needs to be very user-centric. Otherwise, it will simply not work with users to entrust it. So Ampex has developed a platform that aims to be agnostic to different HEMS of specific appliances and devices, but also aims to be very transversal and very holistic. Of course, there needs to be integration of big loads, meaningful loads like EVs, residential batteries, but we're also seeing appliances to be accretive, small accretive, but to be meaningful when it comes to having a solution that is seamless and that is also provides a single interface for the user to deal with everything which is energy consuming or energy producing in their premises. So we have developed a digital energy assistant that we've named Alice. Alice stands for Agent for Lifestyle-Based Intelligent Control of Energy. And what it does is essentially behind the meter mapping what, all the different nodes that are responsible for either generation or consumption. Once it's done that, it starts engaging with the user. And it does that with the aim of learning about the preferences and the behaviors of the users, so that through the machine learning algorithms is then able to not only take account of user preferences, but then adjust those and intervene with the awareness on the other side of what goes on grid. Because it does get price signals and carbon intensity signals into account, so that there is the possibility not only to adhere to dynamic tariffs in the case of a user just wanting to make the most of tariffs that allow them to reduce their energy bills, but most importantly, adhere to demand response requirements so that there is demand side management at a large scale. So what then ALICE does is it stipulates essentially optimal scheduling for different nodes. And as I said, it does do by accounting for user preferences, and the user can always override if ever there's a need for them to take back control of a specific appliance, a specific node, and remove that node from otherwise a scheduled task. The usefulness and the strategic value of an offering like this is explicated not only with the likes of a retailer and aggregators, because a retailer can broaden the type of tariffs that can be offered to users, because they can be as dynamic, technology aided in that adherence of behaviors to patterns and tariffs. But it's also clearly beneficial to the system, because if we think about demand response and looking at a large scale, we clearly realize that at that point, the edge of the grid and the resi players can truly make an active contribution to that flexibility which is needed. I'm just going to show you briefly, we have developed a user interface because we have deployed this technology within the Energy Systems Catapult Living Lab for a period of 6 months. It's only just come to an end a couple of months ago. And we have, as I said, the aim was to integrate with different types of devices and appliances. So the user interface, as you can see, shows to the user what's happening from each of the nodes' point of view in terms of the total consumption or the total generation, what the impact of that node is to the overall cost for a certain period, or even with a breakdown of the day by day throughout a week. And that also we've developed, because we've integrated EVs into the platform, there is clearly a differentiated view which is specific to the needs of EV charging, smart charging. And you can see that there is, again, a view as to how green a charge is going to be, how cheap it's going to be, because the drivers could be cost on one hand, but we've also seen the users are very sensitive to their impact on carbon footprint. ALICE has actually been shortlisted, the AD awards that were on last night. We did not win, but we were very, very proud to be a very young organization alongside some of the most well-established and incumbents. I just wanted to give you a sense of what we gathered for the Living Lab deployment. We managed to actually schedule a number of many tasks, not only around smart charges, but very interestingly around appliances. At the beginning, one may think, well, how is the user going to react to having scheduled, to having a technology aid scheduling things like washing machine and dishwasher? And actually it was surprising to see the level of delegation that we had, the level of trust, because that user-centric approach allows the trust to be gained by ALICE and the optimal scheduling to happen. And we were actually quite successful in simulating demand response, both a very short notice period of up to an hour or less, and a longer notice period of 12 to 16 hours. And you can see that for 12 to 16 hours, we had almost the entire cohort delegating and allowing us to shape the load, essentially. The savings were very interesting too, to the point that when we came to the end of the deployment, users actually did not want to relinquish the ALICE back to Ampex. They actually wanted for ALICE to be left in their homes. So that was, I guess, one of the biggest indicators that we have managed to successfully implement this user-centric approach and get the users completely comfortable in having technology that determines how their node can play a role into grid edge flexibility. I think that's me at this stage, giving you hopefully a good overview of what ALICE can do and how that intervenes into the topic clearly of home energy management systems that we're discussing today. Thank you.
Super, thank you, Irene. And now we'll move on to Matt from Carbon Co-op. Matt, over to you, and I think you're on mute.
Hi there, everyone. Yeah, really interesting talks so far. Really enjoyed that. So yeah, just to give you a quick sort of introduction. My name is Matt Fawcett. I'm one of the co-founders of Carbon Co-op here in Manchester. So we work on retrofit a lot of the time, but we also work on energy system transition. So we're owned by nearly 500 early adopter members. Who use various of our services, like accessing their smart meter data through our smart meter service. But the element I'm here to talk to you about today in terms of the home energy management system is a project we're involved in called ResCoop VPP. So I will break that down, otherwise Peter will murder me. So ResCoop is a European federation of co-ops, of energy co-ops, and the idea of this project is to produce a virtual power plant so that we can provide flexibility to the grid. So the whole platform is built by co-ops for co-ops. It's built on a full open stack and based on open source home energy management system software. And all of our developments are fed back to the open source community. So that's a brief overview of the energy co-ops involved. And basically, it's about pulling data from various devices in the home and being able to control those devices locally. So we are particularly interested in heavy load devices. So that might be heat pumps, EVs, even immersion heaters. So sort of kilowatt level loads, essentially. And the reason we're doing that is because there is, as has been mentioned by a couple of the previous speakers, there is a need for us to respond as consumers to help the grid to decarbonize. So to soften those peaks and to fill those troughs really in renewable energy generation. So this is the little box. It is a as I think many things are hidden around the home. It's a Raspberry Pi device. Which is a local server in the home, which manages the various different the various different smart home energy devices that we're able to control. So just as it's a Cleantech meetup, I thought I would share our full stack there. So the important thing for us, and this is, I think, one of the real key features of the future of smart home devices, and that's we've integrated, for example, the Zappi car chargers, and they're great. They work really well, but we had to do that by using a hack that someone had done of their control API. So what we're really interested in here is open control standards. So that's things like OCPP, which is the Open Control PowerPoint, I think, for Peter's benefit, for EV charge control. And that means that we can write a single control script and apply that to a range of different vehicles and charge points. So that's really a way of sort of shortcutting a lot of the complex tech work. And it also means that we're assured that in the case of a change within that control regime or within that API, we know it's been tested to work with that open standard. So the element here, this local user dashboard, so that's our HEMS device, and we use a piece of software called Home Assistant, which will run on pretty much any computer. We happen to run it on a Raspberry Pi, and it's one of the 10 most active open source projects in the world, and it's the only one of those 10 that is community driven. So it's not driven by Amazon or Google or any of the big players. It's a community effort, and it has hundreds and hundreds of integrations. So different smart devices you can control, from Philips Hue bulbs to Tesla Powerwalls. So and it provides you with local control of your data, which we also think is something which is particularly important as we move into a sort of era where your data becomes a product in itself. So it's platform and vendor agnostic. So in many ways, it sounds like, the dream that James was talking about earlier of something which is, mass market and will deal with everything. But sadly, that's just not the reality at the moment. So it's incredibly flexible. You can design your own beautiful dashboards, but it's also very complex. So at the moment, it's really not a mass market product. It's for early adopters, for tech enthusiasts. And while that is something they're working on, there is, I think, a role for third parties to do some sort of, to try and take out some of the heavy lifting there. So what does it look like? So it can look like anything you want, because, we provide some basic dashboards like the one on the left here, but you can add whatever you wish to it. So you'll see here, this is someone who has an electric vehicle charger, which we are controlling. They've got a heat battery, which we're also controlling, and we can control that because we know what's being generated from their local PV system. So just to finish off, really, I think there are some things which are very important when you're thinking about your home network. And the first of those really is does the device that you're going to purchase, does it allow local control, or is control only possible via a third-party server? So we've seen countless cases, be it Wink or Insteon, or of people who've invested significant amounts in devices around their home, and then the company simply turns the server off. Be that because they change direction as an organization, like iHome did, or it could be that company goes out of business. And when we're looking at particularly fairly significant investments, so things like heat pumps or EV chargers, it's important to know that and be reassured really that we're always going to have control of that down the line. So does it have an open and well-documented API? So again, this is a question of control, really. So how are you going to be able to integrate that? So in the case of Insteon recently, someone sort of hacked their API backend and was able to allow people to once again control those devices via Home Assistant. But that's really not the future that we want to be looking at, really. If we're going to make the sort of changes which we need to make in the energy system, then we're going to need a much higher level of integration across all services and appliances. And that's going to need to be cross manufacturer. So as I say, open control standards, really important. So if you've got an SG ready heat pump, then we can control that regardless of the manufacturer. If you've got an OCPP vehicle charger, it's a bit more complicated because OCPP is a fairly the way that that's been implemented, I think, is not sort of equal across the board, really. So, but at least if the company has given a commitment that they're going to support those open control standards, then through firmware updates, we're always heading in the right direction. And finally, when you're making your choices, think about the home energy management system that you want to use, think about the devices that you've already got, and then select based on devices that will be interoperable with your existing equipment. So just to give you a few links there to end. So that's the project website, our website, our smart meter service, Home Assistant, and just a quick plug for our next Eco Home Lab meetup, which is a meetup which we used to hold in person in Manchester, and we now hold over the internet. And the next one of those that we're holding will be a skill share on how to use Home Assistant automations to control the various different smart home devices in your home. So anyone who's interested in that would be very welcome. So I think that's it from me to leave enough time for questions. So thank you very much for listening.
Thank you very much, Matt. What I'm going to do is I've noticed quite a few of the questions that were being asked in the chat have been answered by the appropriate people. There's also an opportunity to ask them in the breakout rooms, which we'll have after we had the questions and answers. So some of them I won't actually kind of raise right now. In fact, I think I'm going to probably raise two more general questions around the whole of this space. And I'd like to perhaps start off with a debate about kind of off-peak energy being lower carbon. It's been raised a few times. Does anybody of the speakers do go off mute if you feel you want to kind of comment on the whole debate about is off-peak energy always lower carbon? Any thoughts, anybody?
Well, I think it got directed at me originally, given that I went and made the statement about it. I would see it as a general correlation. Off-peak energy tends to be lower cost because it's lower demand, and that means a higher mix of renewables in your generation than at a peak time, when just by the nature of it, renewables are not necessarily able to fulfill as much as they could at an off-peak time. So renewables being cheaper means that that energy becomes cheaper, and it also becomes lower carbon. Obviously, it's a balance. So pretty much the perfect scenario would be a low demand day in summer, a very windy summer day with lots of solar generation, lots of wind generation with low demand, let's say at about 10 o'clock in the morning, is probably going to be the best time. That's probably not what you would call typical off-peak, but it's certainly not a peak demand in terms of when it is. So I would say it's a general correlation, but it's not an exact correlation. But there are forecasts of grid carbon intensity, which are available from the national grid, which can be accessed. So for example, charge your car when it's lower carbon, or heat your home, charge your battery, heat your water tank when it's lower carbon. So those sorts of triggers can be used, but also lots of other triggers. So I think there's a correlation. It's not an exact science, but it's near enough. And you can use other factors if you want to go and do it precisely.
Thanks, Mark. Any other speakers want to kind of challenge that or generally agree with that?
I think I made a similar comment to Mark. I would agree with Mark's. It is a generalization, and you can go to the there is a website that, as Mark said, that you can go and actually look at it and you'll get a 24-hour prediction. So
thanks, James. Yeah, I'm going to move on to the other more general point, and it's the whole debate about open sourced, open APIs. That's an API being an application program interface, and the development of proprietary systems where in effect they're closed systems. So I know we've had some discussion about that, or some speakers have been pointing out about what they are offering in that area. But does anybody else want to expand upon this whole issue and where you see the market actually developing? Are we going to be going to purely proprietary systems where there's in my opinion, possibly end users may have very limited ability to control them, or are we going to end up with more of an open source solution or an open API solution in that respect?
Happy to take this one to start with anyway, because we're very sensitive to this topic. To us, is an enabler that needs to come into play. So open source is the way, and interoperability is an absolute requirement. There simply cannot be demand response from the edge of the grid, and there simply cannot be democratization of the energy system and empowerment of end users, which is not just a matter of principles, because we want end users to be participant. But it's a need of the energy system to be able to rely on that level of flexibility. And unless there is the possibility for technology players to integrate different types of nodes, there cannot be flexibility on that scale, which is something that is essential to the paradigm of decarbonizing the grid. So interoperability, open source, an absolute need, I would say. There shouldn't be a doubt on how important that is. Essential.
Just to add to that, there's a difference between open source and open standards. Open standards are important. You may have closed source, but just going back to what I mentioned earlier in my talk about EE-bus, it is an open standard, but there is only one vendor of software, and that's probably one of the reasons it's not very popular and adopted outside of Germany. The things like Matter is an open software SDK that manufacturers like Geo and other companies can actually go and download for free and actually then develop products on. And because you've got that community developing and fixing the bugs, then with open source you do get a lot of benefits from making sure that those bugs are fixed, etc. So.
Yeah, I mean, I think while we would love to see a totally open source stack, and we think it would it could in some ways speed development. I think my main hope for the future is in, as James says, open standards, really. So I think just because from a consumer level, it's a nightmare, isn't it? I mean, if you've got Google devices and then you've got Apple devices, and so I think Matter is going to be very important in that. I think there is a role for regulators in this, as we've seen with the much publicized USB-C on the iPhone. I think things that we can do to sort of speed the adoption of those open standards is just going to be better for consumer journeys, really.
So do we have regulators that can regulate this area or not? Open question to any speaker.
Well, I think government don't want to mandate anything in this area. They want to see standards naturally evolve, but then they may sort of encourage strongly or signpost that the appliances you buy need to meet a standard, i.e. they need to be supporting DSR, for example. They are probably likely to let industry make the selection. It might be OCPP for charge points, it might be Matter for other things. I don't think government wants to sort of dictate that, but from what I've been discussing with parts of BEIS, etc., in those areas.
But is it not going to help to decarbonise if these standards and so on can actually be kind of speeded up or agreed upon more rapidly? So it can be a very long process of getting kind of manufacturers to agree with such things like this.
So that's, I think, why government did publish this PAS 1878, because they saw a gap in the standardization. They wanted that developed. They kickstarted industry to really say, look, we want you to do this. So they sponsored that, but they don't want to probably go as far as saying, these are the bits and bytes that we're going to tell you how to do, because they want innovation and manufacturers to come up with that side of things. So I think it would be better, as I said at the end of my presentation, to have some trust mark icon that consumers can get behind and know they're going to work. There's a risk if governments mandate a particular standard for UK that the rest of the world goes off and does something different. And again, they want to be careful at this stage to say, well, let's see what comes out of the international standards before we go off and, we might see how international standards develop and then say, actually, yes, 3 years time, that's the one we want everyone to follow. But I don't think doing it now would be a good thing.
So what's the timescale on all this in terms of getting agreed standards and so on? Is it still a long way off? Is the demand from consumers going to be greater than actually can be met by companies to get this standardization?
Maybe I can talk about that from our own personal experience. So our goal was to deliver a solution that could be implemented immediately and put in place. It was actually astonishingly difficult to be able to integrate in different components on the basis of every one of them has a different API. So simple things like if you want to control a heat pump, every one of those heat pump uses different registers to be able to go and control the different functions of it. Some inverters or a lot of inverters don't allow you to go and control them. So there's no ability to control an inverter and a battery. And again, each of them has their own different APIs for controlling them. So we went down the route of, to be able to get a solution out and to market immediately, we had to pick certain components that provided APIs that we could integrate. But being the size of organization that we are, we don't have the resources to be able to integrate in 1,000 different APIs to integrate all of those different solutions into it. So ultimately, standards have to be the direction. So open APIs to control devices in specific ways. But the problem with open standards is, and I come from an IT background, so I'm very used to the whole concept of open standards and everything associated with it. I've been doing this for 30 odd years, is open standards tend to be only a subset of the total functionality that is possible. So if you want to integrate everything, you go with an open standard. But if you want to be able to do the really clever, innovative stuff, that usually means pushing the boundary, and specific products offer specific bits of functionality which are not available from in the general standard. So it's a bit of a compromise and a bit of a balance. Standards are important, but they're not the be all and end all. And the sooner the better, from my opinion, because it means we can integrate more stuff into our platform.
Thanks. And yes, certainly from me as a consumer's point of view, trying to get an API kind of out of my battery manufacturer has been a bit of a job. But I know, and I'm not technical, I know roughly what I want to be doing, but getting the different manufacturers to talk to each other has been having some difficulty, but at least having the ability or being able to or being lucky in order to be able to try out some of these devices. At least I hopefully at some stage will be able to, from a consumer's perspective, influence some of these people.
At the moment, I imagine you've got multiple different apps for every single one of them, and they don't really talk to each other at all. So it's and you're controlling all of that yourself. So you're telling it when to turn on and off, when to use the agile tariff, and trying to guess the weather forecast.
That's exactly the problem I've got as an early adopter, as a consumer in that respect. Can I thank all the speakers? That's been very, very interesting, very useful. Hopefully, participants have been interested in what has been said today. There's still an opportunity in order to go into one of the breakout rooms. As far as I'm aware, all the speakers, I think James may have to leave actually from memory, but I think all the other speakers will be able to stay on. And I think we've run on a bit longer than what we planned, but if we actually say that we can go into the breakout rooms, and Irene will explain that in a moment too, and we've got about 15 minutes available for you to, every participant who wants to do so can ask individual, almost like one-to-one questions with the speakers by going out into a breakout room. So thank you again very much for all the speakers. Thank you for those who are attending. I'm going to pass over to Irene, who's going to explain the procedure for going into a breakout room.
Hi everyone. Thanks again for the speakers, and thanks for all the attendees who joined today and for the ones who are still here today. So what I'll do now is I'll open the rooms. For the speaker, you've been assigned a room. For the attendees, you will be able to move around and decide where you want to go and which speaker you want to have a conversation with. So the room should be open now. Yeah, and I will stop recording as well.